In the last lesson, we talked about the view controller lifecycle, and we've seen methods like view did load, view did disappear, all of these in action. The iOS operating system automatically calls these methods as a view controller is being created, becomes visible, or recedes into the background. But a view controller is just a single screen, right? So what about the app as a whole? Well, for that, we need to zoom out a bit and look at the bigger picture. We need to look at the application lifecycle. And the app's lifecycle usually starts with the app being launched, to the app being visible, and then the app receding into the background, and finally the app being destroyed and the resources reclaimed for other apps. That last part is actually a key to understanding how iOS works. Resources like CPU time or memory are limited, and the operating system always has to decide how to allocate these resources. So how does iOS decide what to prioritize? Well, it prioritizes whichever app is running in the foreground, because that's what the user is looking at, and that's what they're using right now. But why does this matter to you as the app developer? Why should you care about the app lifecycle? Well, imagine your users are playing your game and they just beat a boss, or your users just filed a super long registration form. If your app now goes into the background and iOS decides to reallocate your app's memory to another app, then your users will lose all of their progress and all their data, unless you've already saved the app's data. But how would you know at which time point to save your users' data? Well, you should do it at the point in the lifecycle when your app is going into the background. So that's one example. But thinking back to our chat application and working with Firebase, we've come across another use case for the lifecycle methods as well. Say you need to do something before any other part of the code in your app is executed. Well, in the case of our chat application, the very first thing we needed to do was to configure the app. And that's why we added Firebase app.configure into the application did finish launching with options lifecycle method. That way we could configure our app and read the Google service info.plist from the disk before anything else could happen. So that means application did finish launching with options. This helped us respond to the event of our app being launched and guarantee that this code was executed before anything else. So where can we find these app lifecycle methods? If we take a look at our bog standard sort of template for any iOS app, you'll see that from iOS 13 and any new apps created using Xcode 11, you get an app delegate and a scene delegate file for free anytime you create a new iOS app. It's in these two files, the appdelegate.swift and the scenedelegate.swift files, that the app lifecycle methods are found. So what's the difference between these two files, and what's a scene anyways? Now, previous to Xcode 11, we only had one file, which was the app delegate, and this was the file where the iOS operating system would let our app know which point we were in terms of the app lifecycle. So that's how it was for iOS 12 and below. All the lifecycle methods used to be in the appdelegate.swift. But as of iOS 13, and especially with iPadOS, apps now can run in multiple windows. What this means is that there can be multiple windows running different instances of your app. In other words, there are two separate scenes. That's why we now get a scene delegate that reports back to us on the lifecycle of each of these windows. If one of the windows goes into the background, then the scene delegate for that window gets notified. So if you're a developer who's come from iOS 11 or iOS 12 development, don't be surprised by the scene delegate. All it does is it treats each of these windows being open as a separate scene. So the way it works in apps that support scenes is that events that are common to the app are handled in the application delegate, and all the other lifecycle callbacks are in the scene delegate. So what's common to the app as a whole and handled by the application delegate? Well, it's things like being launched or receiving a time change from the network carrier. And what about the scene delegate? What does the scene delegate handle? Well, it'll be things like a window becoming visible or going into the background. This is very similar to the view controller in a way. The way that it all fits together is you can have multiple view controllers in one scene, and you can have multiple scenes in one application. And each of these have lifecycle methods that you can override. So let's take a look at some of these points which we can override. For example, we've already seen in the Flash Chat app that we can tap into this did finish launching with options method in order to set up Firebase or create a new database or whatever it is that we need to do as soon as the app launches. And then later on, at other points of the life cycle, for example, if our app was interrupted by a phone call, right? Let's say mom calls us and we were in the middle of filling in a form, then it's a good idea for the app's developers to put some code in here to deal with any of these temporary interruptions. So let's say that we were playing some music in Spotify and a phone call comes in, then it's a pretty good idea to tap into these methods and maybe pause the music or turn the volume down, or whatever it is that you may need to do. And then there's other methods like scene did enter background. And this is the moment when your app goes from the foreground to the background. And this is a really good time to save a user's data. So if they were filling in a form and it so happens that the app enters the background, then it's a good idea to actually save what they've typed in, because the next time point where the app actually gets destroyed can be unpredictable. Let's say that the user decided to play Fortnite on their phone and it's requesting a lot of resources, then your app that's resting in the background might actually just get killed silently. So as soon as your app or your scene enters the background, then you can use this part to save any data that's associated with the user so you don't lose it. And the next time that the scene enters the foreground, so when the window comes back online, then you can use the data saved there to repopulate any of the fields that might be empty. So similar to before, I've added some print statements in each of these methods so that we'll get to see at which time points they get called. Now I'm using this syntax when writing print # function, and what this will do is it will print the name of the function. So in this case it will be application did finish launching with options. So let's go ahead and hit run and see which of these methods get called when. So notice how as soon as my app launches, the first thing that happens before anything else, before view did load or before anything like that, is the application did finish launching with options. So that's the first entry point. Next, it calls scene will connect to with options, which is what creates our new scene and shows this new window. Next, we actually see some methods from the view controller. So the view did load being called, view will appear being called, and in between view did appear and view will appear, our scene enters the foreground and becomes active. Now, the next things that I do inside my view controller don't affect the app lifecycle. But if I go ahead and bring my app into the multitasking screen, like so, then you can see that my scene will resign active has now been triggered. Now, if at this point I navigate to a different app, then you can see that my scene actually enters the background. Now, don't worry if you see a warning message like what I've got here. It seems to be a bug in Xcode itself, and it's actually not related to the warning that it's giving you. Hopefully at some point the Apple team will fix this and you won't actually have to look at this warning message. But in case you are, don't worry, it's nothing related to what you've done. So now that my scene has entered the background, if I go ahead and find it on my home screen and launch it again, you can see that the scene now enters the foreground and becomes active. But if instead of navigating to a different app, but instead I actually just click, drag, and throw it away, then that destroys my application and the application did discard scene sessions gets triggered. And this is a point where my app gets killed. So all of these different time points are there for you to tap into, depending on what needs you have. And if you want something to happen before something else happens, or after something else happens, then you can use a variation of the app lifecycle methods, the scene delegate lifecycle methods, and the view controller lifecycle methods to be able to achieve this. So I hope that's been informative. If you want even more details on the app lifecycle or the view controller lifecycle, then be sure to check out the course resources page where there's some links to some extra reading if you want to know more. But now that we've completed the Flash Chat app, it's time to review the code that you've written, and if there's anything in there that you don't understand, then be sure to review the lessons where we talked about them so that you're ready to move on to even more advanced stages in the next modules. So that's all from me for this module, and I hope to see you on the next one.